Hello everybody. In this video we are going to go ahead and set it up so that our camera will follow our player as they move through our platformer, but also so that the camera cannot move beyond the left and rightmost bounds of our level. Now, before I started this video, I went ahead and built out a slightly larger level than I had before, and that's just so that we have space for our camera to actually move along following our player. Right now you can see that the camera is set right here. You can see that by the green outline. It doesn't technically matter because we're going to be using code to go ahead and update the position of the camera at a fixed rate using fixed update method. Alright, so looking at this, we know that our player starts over here on the left and moves to the right. Our camera, here's our shape, we want the left side of the camera to stop roughly right where we are right now, no matter where the player is. When the player reaches about the center point here of the camera should follow the player. And then when the rightmost edge of the camera reaches the rightmost edge of the map, we want the camera to stop even if the player keeps going. So first thing we're going to do is we want to set it up so that we can define where our left and right bounds are in our game. And we're going to do that using empty game objects. Now, how those work is over here in the hierarchy, right click and choose create empty. That literally is going to create for you a game object that is basically just a blank object that exists in 3D space. And we're going to call it border camera left. And then we're going to make a duplicate called border camera right. Alright, and we're going to go ahead and for the leftmost one, up here we're going to select it in the hierarchy and then we're going to choose the arrow keys. Now we're going to move it, and we want to make it so that it's pretty much where the camera is, if your camera is set up like mine. If it's not, then that's fine, don't worry about it. Just, you want the left edge of this, when you highlight it, gold box, where the red and green arrows meet, to be near the edge of our world. And then for the camera right, let's go ahead and let's drag that, and its Y position doesn't matter where it is on the Y axis, it's all about the X position. We're going to do it so that that corner, again, is right within the bounds of our map. Alright, so we've created what our left and right bounds are. Now we need to go ahead and tell the camera to A, follow the player, and B, to respect those bounds. So let's go ahead and, down in Assets, Scripts, we're going to create a new C# script called camera follow. Now let's go ahead and open that up. We're going to do a couple things here. First, we want to define to the camera a transform, so basically a positional object that would include position, rotation, scale, that we want to follow. So follow transform. Now what this is that we're going to go ahead and with this public variable, we're going to put the player in here, and that will cause the camera to follow the player object's position, okay, following its transform. We're also going to go ahead and put in here a private vector3 smooth position, and this will come into play a little bit later. I'll explain it when we get to it. And then a private float smooth speed. And again, this will come into play when we deal with the smooth position. So just for now, enter those. We also want to include two game object variables. One is our camera left border, and another one is our camera right border. And making them public, we'll be able to go ahead and take those two empty objects that we defined in Unity and drop them into these inputs on the camera follow script. And finally, let's go ahead and create a private float camera half width. And as you can imagine, this is where we're going to store half the width of the camera, and that will be so that we know where to position the camera in relation to our left and right borders. And we're going to go ahead and change the void update method to a fixed update. All right, now go ahead and save the script. You've got your variables, and let's go back to Unity here. Go ahead and take the camera follow script and drag it up and drop it on the main camera. And then select the main camera and it should be on there now. And follow transform, camera left border, camera right border, they should all say none currently. Go ahead and from the hierarchy, drag and drop the player for the follow transform, and then drag and drop the border camera left and the border camera right from the hierarchy to their inputs in the inspector, to their respective fields. So obviously border camera left will go on camera left border field, and border camera right will go in the camera right border. It should look something like this. Let's go ahead and go back to Visual Studio. Now there's going to be a couple new things here that might seem a little unfamiliar, and some of it you might have to go on faith that this is just how it works. There's nothing special, no special knowledge that I have about these. It's all about just experience and having done this kind of stuff before. You learn Unity's API. Now, first thing we need to do when our camera loads up is we need to go ahead and figure out, okay, what is actually half the width of the camera? And we can do that by accessing the camera object main. Now, camera.main will, by default, choose the first camera that is in our scene. Or if there's only one camera, it'll choose the only camera that is in our scene. We only have one camera, so we don't have to worry about what this is going to pick. It's going to pick the correct camera for us. So camera.main. Now we are doing a 2D game, so we have an orthographic camera. And we want to get the size of that camera, which you see here, orthographic size gives you camera's half size in orthographic mode. Now that's going to give us the half size. We need to take into account the fact that the camera's aspect ratio will affect what that half size should actually look like. So we want to multiply it by camera.main.aspect. And that will give us half of our camera width when our game is running. Now with that in mind, we're going to go ahead and we need to figure out what is actually the leftmost border in our game world. We define a float called border left, and we're going to go ahead and get the camera left border, that empty game object that we defined, and we're going to get its X position, and we're going to add camera half width to it. Now, the reason we need to do that is because if our border is right here, we don't want the camera to be able to go ahead and move to that position. We want it to be that the camera can get to this position plus half the camera, which will go ahead and make sure then that the leftmost edge of our camera doesn't go past. The camera's position is defined by its midpoint, which is why the camera could end up like this, and what we need is for that position plus half the camera width. And then we're going to do the same thing for border right. And border right, we're going to go ahead and just update these variables so that we're getting the border right, and we're using camera right border, but everything else is the same. And then I'm going to go ahead and drop in some code here, and then I will explain it. So first, smooth position. We define that up here. It's a vector 3, so a position in 3D space. We're using vector3.lerp to get our smooth position. Now what lerp does is it takes a position in 3D space, it takes your current position, and it takes the position you want to go to, and it allows you to define a amount of smoothness you want to apply to that transform. And what it's basically going to do is it gives you a position that will be somewhat of a midpoint, basically a gradation of moving from point A to point B, so that it kind of is smoother, more animated feeling, and it's not just cutting from point A to point B. That's what lerp does. And then what we do is we give it the current position of the camera, and then we're trying to define a new position. Now, we want the camera to remain on its Y position. We don't want it to move up and down. Z, we don't care about Z, but we have to define it. We don't want the Z to change. What will change is the X position, camera moving left to right. So what we call here is math. We're calling the math object dot clamp. Now clamp will go ahead and say, give me a coordinate, give me a value, and then give me a min and max. And if the value you have given me is below or above the two min and maxes, then I'll go ahead and I will modify it so that it fits between them. So if I give it a min and max of 0 and 1, and then I pass it a value of -1, it will move that so that it is now 0. It cannot be below or above the min and max. So right here we go and say, all right, take the player's position, what we assigned to follow transform, take our border left and our border right, which we defined up here. Those are the left and most right points in the game world that we want our camera to be able to go, and say, hey, if the player's position is below or above, clamp it so that it's not past that point. Okay? And this isn't taking the player's actual position, it's just taking that value. So now we have the X position that we want the camera to be. It can't be past the left and right border, but it will follow the player as closely as it can as long as it stays clamped between these 2 points. And then, last but not least, we will go ahead and actually position the camera. If you go ahead and save this, go back to Unity, and run your game. Now notice how the camera doesn't move, just like we're used to seeing. Okay? And as I move away from the leftmost edge, the camera follows me. And I went ahead and got something wrong over here, and I know exactly what that is. Go ahead and close our code and go back. We're closing and go back to our code. Here where we define border right, this right here should be a minus, not a plus. We want to move from the right-hand side inward by half the camera. Just like from border left, we went from the leftmost point inward. The other way by half the camera. Let's go ahead and run that and test that one more time. Okay, so we are not moving to the left. If we go back, the camera will stop. Good. And then as we move to the right, the camera should stop right when it hits the breakpoint. And I place this rock here on our interactable layer so that I can't move past that. I could jump over it. But if I move this way, the camera will follow, and I go back, and there it is. And that is how you go ahead and define a follow camera script. That will go ahead and honor whatever 2 points you place in 3D space. You can go ahead and look online and find a lot of solutions about how to deal with keeping the camera from moving past certain points. The reason that I like this solution is that it doesn't deal with colliders. It allows me to go ahead and freely place where I want my left and right borders to be. And it goes ahead and uses a pretty simple small function here to process the calculation and figure out where the camera should be in relation to whatever object I'm following.